Hello, friends. This is Jim here with Science Talk. I want to share with you a little summary of a study that was published on the phys.org site. And this study identifies new cause of melting Antarctic ice shelves. Okay, what do they have in store for us? Well, first of all, there's the photo of the Thwaites ice shelf in Antarctica. You can see there's some calving and some fissures and splits and cracks and so forth. Researchers have discovered a process that can contribute to the melting of ice shelves in the Antarctic. An international team of scientists found that adjacent ice shelves play a role in causing instability in others downstream. The study, led by the University of East Anglia in the UK, also identified that a small ocean gyre, a system circulating ocean currents, next to the Thwaites ice shelf can impact the amount of glacial meltwater flowing beneath it. When a gyre is weaker, more warm water can access the areas beneath the ice shelf, causing it to melt. The Thwaites ice shelf is one of the biggest ice shelves in West Antarctica and buttresses the eastern side of the Thwaites Glacier, which has been retreating rapidly over the last 20 years and is the largest contributor to global sea level rise among Antarctic glaciers. Using a unique data set collected by sensors installed beneath the Thwaites ice shelf, which has also thinned and weakened significantly in recent decades, the researchers observed that the shallow layers of the ocean underneath it warmed considerably during the period from January 2020 to March 2021. Most of this warming was driven by waters with a high volume of glacial meltwater, originating from Pine Island ice shelf further east, flowing into the area beneath the Thwaites ice shelf. Glacial meltwater mixes with salt water when the ocean melts the base of ice shelves and can form a buoyant layer of water that is warmer than the surrounding waters. This lighter, relatively fresher, and warmer waters brings heat that melts the base of the Thwaites ice shelf. Lead author Dr. Tiago Dodo of the Center for Ocean and Atmospheric Sciences at UEA said, "We have identified another process that could impact the stability of ice shelves, revealing the importance of local ocean circulation and sea ice. Circumpolar deep water, a warm variety of Antarctic waters, is a key player in melting the base of ice shelves. However, in this study, we show that a great amount of heat at shallow layers beneath one ice shelf can be provided by waters originating from other melting ice shelves nearby. Therefore, what happens to one ice shelf can impact the adjacent ice shelf, and so on. This process is important for regions of high ice shelf melting, such as the Amundsen Sea, because one ice shelf sits next to the other, and the export of heat from one ice shelf can reach the next one via ocean circulation." Dr. Dodo added, "These atmosphere, sea, ice, ocean interactions are important because they can prolong warm periods beneath ice shelves by allowing warm and meltwater rich water to enter adjacent ice shelf cavities." Cavities, that's key. Get into that space there, and that water can persist. Gyres potentially existing in other regions around Antarctica may also cause a greater number of ice shelves to be prone to intense basal melting associated with prolonged warm conditions, and as a result, further contribute to global sea level rise. In January 2020, colleagues from the U.S. drilled holes in the ice and installed sensors monitoring temperature, salinity, and ocean current beneath the Thwaites ice shelf. For more than a year, these sensors sent via satellite the data used to identify the ocean variations. For example, how the temperature and meltwater content varied. From these observations, the researchers suspected that the excess of heat could not have originally originated locally at the Thwaites ice shelf because they did not see strong melting at the sites where those sensors were installed. So they combined the info with computer simulation to identify the origin of this heat. They found that the water that leaves the Pine Island ice shelf can access the areas beneath Thwaites ice shelf. Again, Pine Island and Thwaites are next to each other. So what this is saying is the heat and the water from Pine Island is affecting Thwaites. The mechanism that explained how these waters access the Thwaites ice shelf was identified by using model simulations and data collected by tags attached to seals. They both show that a gyre near the Thwaites ice shelf weakens in winter, which allows more heat to reach the shallow areas beneath the ice shelf. Satellite images also show that the Southern Hemisphere summer season of 2020-2021 was unusual because it had a high concentration of sea ice in regions near the Thwaites ice shelf. Drawing on the simulations and previous research, the team hypothesized that the gyre was even weaker, so the excess of meltwater from adjacent ice shelves could not be moved away from the region by the currents and instead enter the Thwaites ice shelf. This further reduced the strength of this gyre, which enabled more water to inflow. So we had an increased inflow of water with higher concentration of glacial meltwater beneath the ice shelf. So basically, the gyres are enabling warm. We have meltwater. We have the gyres weakening, allowing this warmer water to get inside the Thwaites ice shelf, and it's warming from the bottom. But then it's also allowing it to do what? It's melting the basal, we're kind of, like past the grounding line there. So it's getting at the base of this all, it's melting that. It's then, if you start melting that and that starts breaking off, then the glacier that's behind it, that is on the grounding line or up, can now move further down. But this is showing how one thing that's happening elsewhere can affect adjacent regions. And it's not merely atmospheric temperatures that are melting Antarctica, but is the increased heat content in the oceans that are melting it from underneath. So you got above melting, below melting, and now with a better understanding of currents specifically in the region, that can help bring in warmer water to further increase the melting. So this is impacting Thwaites Glacier, but it gets to the point where it starts increasing the melt rate for Thwaites Glacier, then Pine Island is next. This is very troubling, and this will lead to extremely noticeable increases in sea level. So another mechanism to explain the rapidly melting ice shelves. All these mechanisms add up. Thank you for your time. Until next time.